Today's lesson will be about establishing identities. It's sort of like doing geometric proofs. I know that scares some of you. And there will be some challenges in these first few days of this chapter, but we will get through it and then it will be downhill from there. So hang in there with me, okay? Establishing identities are where I'm going to give you an equation that we already know is true, but you have to prove that it is true. Okay? So your goal is to make one side of the equation look like the other. Typically you work with the left side, so typically you turn the left side into the right, but there are some rules to it. You can only work with one side of the equation at a time. You cannot manipulate both the left and the right side of the equation, and you can't move anything across the equal sign. So you can't add something to both sides or whatever. That is illegal. And I will give you a little tips and tricks worksheet in class that you can use, and it'll also be on Moodle so that you can use, and when you get stuck, it will be a place for you to look in terms of knowing maybe what to try, okay? Every one of these problems is a little different, and so the way you get better at this is to do problem after problem after problem. So I know it's going to be a little bit frustrating. Sometimes these are a little hard to see, but you will get better at it, and I will help you with that, and we will go from there. But here's our first example. This is a true statement. Cosecant theta times tangent at theta equals secant theta. I already know this is true, but I have to use what I know about some trig properties to prove that this is true. So one of the biggest things that you're going to use is these trig proportions right here. You're going to have to get really, really used to them because you're going to use them a lot, okay? My theory when I try to do establishing identities is to, when in doubt, kind of change things to sine and cosine. In this case, I don't really necessarily need to do that, but you'll see what happens here. Okay, so what I'm going to do is I'm going to use these trig proportions, and I am going to change cosecant to 1 over sine right here. You can see that cosecant can be rewritten as 1 over sine. So when in doubt, change things to sines and cosines, okay? So cosecant, I'm going to rewrite as 1 over sine. Tangent, I'm going to again use these trig proportions. Tangent can be rewritten as 1 over cotangent, but that's not going to do you a whole lot of good. It can also be written as sine over cosine. So I am going to rewrite tangent as sine over cosine. Okay, then we can use some algebra and realize that the signs can drop because I'm multiplying. If I was adding, I couldn't do that, but I am multiplying, so I can. What I have left is 1 on the top and cosine on the bottom, okay? And if you look again back at these trig proportions, 1 over cosine right here is secant, okay? So 1 over cosine is secant. Okay, so basically I'm giving you a problem. I already gave you the answer. You just have to turn it into the answer, okay? There is no like end result that you're going to circle. When I correct these, I have to be able to follow every single one of your steps and know what you did along the way. So all of your work to this is an answer. There's not one like end answer that you're going to circle, but I just did turn the left side into the right side. I turned cosecant tangent into secant. This is not the only way you could have done this problem. Many of these problems have multiple ways to do it, and as long as you make legal moves and use correct properties all along, there's no one way or right way or wrong way. There's multiple ways to do these, some of them, okay? So we're going to move on to the next one, and hopefully you'll kind of start getting a gist here. Here's the next one. Sine times tangent plus cotangent equals secant. Again, my train of thought is if you have no idea what to do, change everything to in terms of sine and cosine. Okay, so I'm going to leave this sine theta out here. I am going to again use my trig proportions and realize that tangent can be rewritten as sine over cosine. Okay, so I'm going to rewrite tangent as sine over cosine. Cotangent, if you look, can be rewritten as cosine over sine. And then that equals secant. And by the way, you guys, on the next test, you're not going to get those trig proportions, so you need to be practicing on knowing what can be rewritten as what. I know you have them on your notes in front of you so that we had something to refer to, but you're going to need to be able to wean yourself off of those because I'm not going to give you those proportions on your test, okay? Now, you can do this one of two ways. You can either distribute that sign through the parentheses, or you can get common denominators inside the parentheses and then figure it out from there, okay? I like to get common denominators so that this is kind of cleaned up a little bit. So I'm going to get common denominators in here. And so my common denominator between cosine and sine is sine cosine. So I need to multiply this side by sine over sine so that I can get a common denominator, and this side by cosine over cosine, okay? Then my common denominator will be sine cosine. And then right here, I have sine squared. And right here, I have cosine squared. Okay, and then clearly I have this sine out in front. And by the way, this is sine over 1 right now, okay? My goal is to turn that left side into secant, so I'm still working there. Okay, now some properties that you can kind of figure out. First of all, this sign and this sign can drop. There's a multiplication symbol in here, and as long as it's multiplying, you can cancel any part of it. If it was addition or subtraction, you would have to think of that as one whole entity, and you couldn't cancel just part of it. You'd have to be able to cancel the whole thing. So I'm there. Then this right here, if you look at your trig identities, and this is one you should know, everyone's got to know this one. Right here, sine squared plus cosine squared is always 1. And there's a big hint. Whenever you have squares in your equations, you're probably going to need to use an identity. Sometimes you'll factor it too, but you're likely going to need to use an identity. And that is one everybody should know, that sine squared plus cosine squared is 1. Okay, so now I'm back here. So sine squared plus cosine squared is 1. And so what I have left is I have 1 over cosine. And again, if I'm looking at my trig proportions over here, 1 over cosine is secant. And I just turned the left side into the right. Okay, moving on. The next one has some squares in it, so we're probably going to need to use some identities here. And we've got these weird negatives in there with even and odd properties, okay? So just so you know, on this one, this is kind of weird, but we know that sine right here is an odd function, so that negative needs to go out in front, okay? And down here, cosine is an even function, so I can just drop that negative. I don't need it. So what I have down here is I have negative sine at theta minus cosine at theta. Okay, that's in my denominator. Now, in my numerator, I need to talk about this. This right here is really saying this, sine at negative theta squared, okay? And when you square something, and actually I should actually show you it this way so that it makes a little bit more sense. Sine is an even function, an odd function, so I would take that negative and I would pull it out in front. So I really have this, negative sine at theta and then squared, okay? In trig, we write the squared right here for some reason, but it really means take sine at theta and square it. I don't know why they write the 2 there, but they do. Anyways, when you square a negative times a negative times a negative is going to end up being a positive. A negative times a negative will be a positive. So even though this function right here is an odd function, and I would have to take the negative out, because I'm going to square it in the end, the negative actually will disappear because a negative times a negative is a positive. So I really don't need that. So I have sine squared there. Okay. Cosine is an even function, so I can drop the negative right away. Even if I couldn't drop the negative, though, I would pull it out in front, and then I would have negative cosine, and then when I square it, that negative is going to go away anyway, so it doesn't matter. But I still have that subtraction sign in between, and now I'm here. Okay? A lot of people think at this point that I can just cancel one of these signs with one of those, and one of these cosines with one of those, and call it good. But Again, things are separated by addition and subtraction signs. So unless you can cancel the whole entire entity, you can't cancel any part of it. You can't separate what's on the left side of the addition or subtraction sign and what's on the right side. That's not going to work. The other common mistake that people will do here is they'll say that you have an identity on the top because sine squared plus cosine squared equals 1. Notice there's a plus sign right here, not a minus sign. And so you can't replace that sine squared minus cosine squared with 1. It has to be a plus sign in there. So here's what you can do. The top is actually a perfect square. I'm going to just side note this. If we had x squared minus 49, you know that you would factor that as x plus 7 and x minus 7. Same thing with sine squared minus cosine squared. You will factor that. It is a perfect square. So you will factor sine squared minus cosine squared as sine theta plus cosine theta and sine theta minus cosine theta. Okay. Then in the denominator, what I'm going to do is I am going to factor one of these negatives out. Okay, I'm going to factor the negative out, and when I pull a negative 1 out, then I will have sine theta plus cosine theta. Okay. Now what happens is I have an entity on the top and an entity on the bottom that are exactly like each other, so I can go ahead and cancel that. And now I have this left, sine theta minus cosine theta. Whoops, I forgot my minus sign. Over negative 1. And of course, if you take sine divided by negative 1, you have negative sine. And if you take negative cosine divided by negative 1, you have positive cosine. And then if you look at where you need to be, they're just switched around. The cosine is listed first and the negative sign is listed second. So I can just switcheroo those two, and I am there. Okay? All right, so this is our last one of the day. And I have this little video here for you. I don't know if you'll be able to see it, but it's kind of silly. I'll let you watch it. Okay, that was really cheesy. But as I'm looking at this trig identity, some people get stuck about where to start. And one thing you can do is, when in doubt, change everything to sines and cosines. That totally would work. The other thing, and that would work in this case, it would just be longer. What I'm looking at this is I'm looking at the left side of the equation and realizing I have a tangent in there already, and I need to get to tangent on the right side of the equation. But then I also have this oddball right here. This cotangent to me is an oddball because everything else is in terms of tangent. So I'm thinking in my head, I wonder if I can get cotangent turned into tangent somehow. And if you look at your trig proportions, cotangent can be rewritten as 1 over tangent. Okay? So I'm going to change that. So 1 plus tangent over 1 plus 1 over tangent. Okay, so now that's fabulous because I have everything in terms of tangent, but I have fractions within fractions, and that's ugly. Okay, but I can fix that. Right now, this 1 right here is 1 over 1. And your first goal before you deal within the fractions within the fractions is you have to have the whole entire numerator as 1 fraction and the denominator as 1 fraction. Okay, so I need to get this quantity right here as 1 fraction, not 2 things added together. I need it to have 1 denominator. So my common denominator would be tangent, and so I'm going to change this to tangent over tangent. Okay, so then in my numerator, I have 1 plus tangent, and in my denominator, I have tangent plus 1 over my common denominator right here, which is tangent. Okay, so I still have fractions within fractions, but at least I have the numerator is one fraction and the denominator is one fraction. Now, instead of dividing by this fraction right here, what you need to do is you need to kind of flip-de-dipped it and multiply it by the reciprocal. So instead of dividing by this, I am going to multiply it by tangent over tangent plus 1. Okay, and I'm going to cross that off because I multiplied it. Okay, now the top in the red says 1 plus tangent, and the denominator in the blue says tangent plus 1. When you add 5 plus 4 and 4 plus 5, you're going to get the same answer. So it's okay that they're switched around. It would not be okay if they're subtraction, but it is okay since they're addition. And those two quantities can cross out, and you will be left with tangent. Okay? And if you look, that's where we needed to get. We needed to turn the left side into tangent, and we did that. Okay? So this is going to be your homework, and we will talk about it when I see you.